all basic passive elements, resistance, inductance, capacitance is given. All the passive elements is given in the ohm. The unit of all the
Yes, sir.
passive elements is given in ohm. Suppose in a problem, if they given farad for capacitor, if they mention for capacitance, capacitor if they mention farad, and inductor if they mention Henry, then for such a problems in the beginning only you convert all the passive elements into same unit, that is ohms. So
Okay.
here in this problem anyway there is no no need to connect reactance, since the all the elements is given reactance directly. So here
Okay, sir.
any problem?
No, sir. Hello.
Yeah, shall I continue?
Yes, sir. Yes, sir.
Okay. So for this problem anyway all the elements is given in reactance. So by using nodal analysis, by applying nodal analysis, you have to calculate the node voltages. So here how many nodes are there by seeing the circuit including the reference node? Can you tell me?
Uh, 8, sir.
How many?
8.
No.
How do you count the nodes again?
How many nodes are there? So this is whole. I'll take one more color. This is nothing but whole thing is one node only, right? This is nothing but whole thing is one node. Since it between there is no branch, there is no elements, and the reference node. So here only 3 nodes are there, including reference node.
3, sir.
Yeah, 3 nodes only.
Okay.
Node is nothing but the junction, the meeting point of node. The definition of node is the meeting point of one or more elements. So here the minus J10 ohm, so here it is the meeting point. So 5 ohm it is the meeting point, and the current source it is the meeting point, and this parallel branch is the meeting point. But here in between all these there is no element, right? So that means all these branches are connected to the same node having the potential, have same potential. So I am considering this branch is having potential V1. So similarly, so this other end of the parallel branches and these 5J ohm and 10 ohm, one second. So 5J ohm and 10 ohm and the current source. This is nothing but another node. So I considered for this node having a voltage V2, and this is reference node or ground node. Right, for this AC circuit, since all the elements resistance, inductance, capacitance, all it's given in the reactance form, so no need to convert. So it's given. So here if you see for AC circuits, here how many independent sources are there? There are 2 independent current sources is given. So one at an angle 0, this is an independent current source in the left side. Similarly in the right side 0.5 at an angle of minus 90. So for all AC circuits, one you have to take the reference, one source you have to take the reference. So here 0 degrees, this is I am taking the reference. So here totally 3 nodes are there, V1, V2 and including reference. So you have to calculate for this problem by applying the node analysis, find the time domain node voltages V1 of t and V2 of t. Since it is a AC circuit, time domain circuit, as the time changes, V1 of t and V2 of t also changes. Whereas in the previous all the previous circuits, all those are all DC circuits. those values, the voltages or currents, those are constant with respect to time. But here this is not the case like before. So here as time changes, the voltages and currents changes. So by applying
Okay.
nodal analysis, so here in the question itself it's told, so by using the nodal analysis technique, calculate the V1 of t and V2 of t. So procedure is same, how you followed for the DC circuits, there is the same procedure. Only thing is here in the place of resistors, here resistors, inductors and capacitors is there. So how you followed for nodal analysis? So this node we have to assume all currents are leaving. So I am considering for the V1 node. So all the nodes, all the currents are leaving at the node 1. So you have to assume like that for nodal analysis. So then write the equation by applying KCL. Nodal analysis is based on the Kirchhoff current law. So just apply by applying KCL at node 1. So write the equation. So V1 by 5. So I am just writing V1 for simplicity. So this current, the current flowing through the 5 ohm is nothing but I is equals to V by R. So V1 by 5 and V1 by, see always the inductance reactance is positive and capacitive reactance is negative. So minus J10 ohm, minus J will come, and inductor reactance is plus J will come. So V1 by the current flowing through the capacitor having minus capacitance minus J10 ohm, V1 by minus J10. Less this current. So this current anyway the value is given, but the whatever I consider the direction which is opposite to the given current direction, so I have to write minus 1 at an angle 0. So 1 at an angle 0, which is nothing but polar form. So do you have any idea how to convert rectangular form to polar form and polar form to rectangular form?
Yes, sir.
Okay, you can use your scientific calculator also how to convert rectangular to polar and polar to rectangular. So the 1 at an angle 0 is nothing but polar, it is given in polar coordinate. So 1 at an angle 0 degrees is nothing but 1 plus J0, which is in rectangular. This is in rectangular and this is in polar.
So what is J again?
J is nothing but imaginary. This is polar. 1 at an angle 0 is given in polar form. So I am converting into rectangular. Do you have, I think you don't have idea about operations in rectangular and polar.
No, sir.
Yeah, in the same problem I will explain. It's not a big thing. So then, so these three currents is
And how did you get, yes, sir, how did you get V by negative J10? Is that current through the capacitor, sir?
Yeah, the V1 by minus J10, that is nothing but J10 is the capacitance, reactance, capacitive reactance is J10 ohm, minus J10 ohm. So V1 by 5 is the current flowing through the 5 ohm resistor, so that is the first term I written, and V1 by minus J10, this is nothing but reactance. Reactance is given in ohm.
Okay.
The reactance unit also is ohm, impedance unit also is ohm, resistance unit also is ohm. So I is equals to V by R. Consider if the reactance, capacitive reactance and inductive reactance is given directly, so you think that those are all like resistance only.
Okay.
And write the equation. So the current flowing through the minus J10 ohm is nothing but I is equals to V by R. So this node having the voltage V1 of t. So for simplicity I am writing V1 only. So V1 divided by reactance I is equals to V by Z for AC circuits. For DC circuits there is no Z is nothing but only resistance.
Yes, sir.
So I is equals to V by Z. So this is V by, here Z is nothing but capacitive reactance. There is no resistance. The capacitor having, suppose one second, here this is R and capacitance. So this is nothing but minus jXc. Suppose this is given, so what is Z? Z is nothing but the impedance. So R minus jXc. The impedance is R minus jXc.
Yes, sir.
But here in this case, here J minus J10 ohm is there. There is no resistor here. So that means resistor is 0. There is no resistor. Resistance value is 0. So Z is equals to minus jXc only. So that's why I am writing only V1 by minus J10 ohm, and this current is nothing but minus, since this I assume direction is from the node, it is leaving node to reference. The current is leaving from the node, and so but one at an angle 0, which is opposite direction to the assumed direction. So that's why minus. Following? Yeah, and this current,
Yes, sir.
this current is flowing across the parallel branches. So here again it divides. This current, so whatever this current, I will draw it some other color. 1 second. So this current I have, so 3 currents is over 3 times, and this current I have to write. So since these minus J5 ohm and J10 ohm are connected in parallel, so in parallel the current divides. So this current again it is dividing to the minus J5 ohm and J10 ohm. So you have to write these currents also in the equation. So plus, so what is the current across the minus J, what is the current flowing through the minus J5 ohm?
Current flowing through minus J5 is going to be V1 of t divided by negative J5.
No. Since the other end of the capacitor is connected to the node V2, so here I have to write potential difference. So V1 minus V2. Nodal analysis. So you revise the, so V1 minus V2 divided by capacitive reactance. So minus J5. And this current is nothing but the current flowing through the J10 ohm, that is inductor. So similarly V1, since the current is leaving at the V1 and entering to V2, so V1 acts as a higher potential. That's why V1 minus V2. So V1 minus V2 divided by J10 is equals to 0. So I just applied the KCL at the node 1. So this is the node 1 having the node voltage V1, and similarly node 2 having the node voltage V2. So V1, V2 we have to calculate. So by using nodal analysis, I written the first equation based on the KCL, by applying the KCL. So any doubt in the equation 1? If you have any doubt in equation 1, I will repeat. Okay, similarly,
no, sir, I got it.
Yeah, similarly apply KCL at the node 2. So all the currents, I have to assume all the currents are leaving. So all the currents are leaving from the node 2. Now this time I will erase this. So this time, so these parallel branch currents also, these like this. Now V2 acts as a higher potential since the V2 is delivering the current in this direction. Since this is assumed direction, all the currents you have to assume are leaving at the node. So write the equation. So V2 by 10 ohm, first the current flowing through the 10 ohm resistor, plus So this current 0.5 at an angle of minus 90, it's anyway it is given. So but the whatever I assume direction and the 0.5 at an angle minus 90 current both are in the same direction only. So that's why plus. So 0.5 at an angle of minus 90 degrees plus, and two terms are over, then V2 by J5, the current flowing through the J5 ohm inductor. So V2 by J5. So next, the current flowing through the parallel branch. So first I am writing minus J5 ohm. So that is nothing but V2 minus V1 so V2 minus V1 minus J5 ohm plus, and the current flowing through the J10 ohm. So V2 minus, since the current is leaving from the node V2, so V2 is higher potential. So V2 minus V1 by, so J10 is equals to 0. So I just applied the nodal analysis technique for the node 1 and node 2 based on the KCL. So any doubt in the node 1 and node 2 equation, writing the node 1 and node 2 equation?
No, sir.
Yeah. So now we know, so just now simplify, now solve the equations 1 and 2. So only two unknowns. If you solve the two equations, two unknowns, you will get the unknowns V1 and V2. But this equation is consisting of real and imaginary, right? So since it is a AC circuit, so real is nothing but resistor values, imaginary is nothing but inductive and capacitive. So you have to write separately. So write the equation. So 1 by 5. So 1 by 5 is 0.2, right? And
Yes.
the basic is J square is equals to minus 1. J square is equals to minus 1. So remember this one. So if you multiply J into J, imaginary into J, you will get minus 1. So from this J...
So this is basically okay, got it.
Yeah, I or J. Some textbooks they will follow imaginary as I, and some textbooks they will follow J. Both are same only. Even in MATLAB also, both I and J are the predefined variables. Those are nothing but imaginary variables. You should not take I and J for other purpose. Since I and J already in MATLAB it is defined as imaginary variables. Okay. So some textbooks they will follow I as imaginary variable, some textbooks they will follow J as the imaginary variable. So J square is equals to minus 1. So from this J is equals to minus 1 by J. So here minus 1 by J is there. So wherever minus 1 by J you can write it as plus J. Okay. So I am just erasing these basics. Since you already know this, J square is minus 1 or I square is minus 1. So now here if you see the equation, first equation, so there is only one real value, only one real term, remaining all the imaginary terms only. So V1 by 5 only real term. If you see V1 by minus J10, so imaginary. So anyway 1 at an angle 0, this is which is constant, and V1 minus V2 by minus J5, here also imaginary.
So basically it's going to be, to write that in terms of I and J, like 0.5 at an angle of minus 90, you're going to be, it is written as, it's written as 0.5 plus, 0.5 plus 0.5 J, no sir?
No, 0.5 at an angle of minus 90, I think 0.5 minus 0.5 J, I think. If it is plus 90, 0.5 plus 0.5 J, minus 90,
Okay.
I think 0.5
minus 0.5
0.5
minus
J, I think. Okay. First you solve the equation 1. So V1 by 5. 1 by 5 is 0.2. So 0.2 V1 and minus 1 by j. Minus 1 by j is nothing but j. So 1 by 10, 0.1. So this is nothing but 0.1 j. V1, and here minus 1 by j is plus j, 1 by 5 is 0.2, so 0.2 j, so 0.2 j V1 I am separating, and similarly minus 0.2 j V2 plus, so here 1 by j is there, so minus j. If it comes in the numerator, 1 by j is nothing but minus j. So here 1 by 10 is 0.1. So here minus. So minus 0.1 j V1, and here minus V2 and here minus. So plus, minus into minus plus, 0.1 j V2 is equals to 1. 1 at an angle 0 is nothing but 1, right?
Yes, sir.
Yeah, so I am solving the equation 1. So anyway, there is no only one term, real term, remaining all are having j imaginary term. So 0.2 V1.
So one problem I think over here. Shouldn't it be because it's over here it's 0.2 JV1, and then shouldn't it be plus 0.2 JV2.
So what are the G1 terms here? V1 terms 0.1 J, 0.2 J, so 0.3 J, and this one get cancelled. So plus 0.2 J, only 0.2 J. So 0.2 plus 0.2 J.
So shouldn't it be 0.2 JV1 plus 0.2 JV2?
So I am writing V1 terms and V2 terms separately. Following?
Yes, sir.
So minus 0.2 JV2 and plus 0.1 J. So minus 0.1 J V2 is equals to 1. So this is the name it as 3. So same equation 1 I just solve in the simplified form. So this is the equation 3. So similarly solve the equation 2. So V1 terms, where are V1 terms? So here V1 term is there, here V1 term is there. So minus 1 by j. So minus 1 by j is nothing but plus j. So 1 by 5 is 0.2. So minus, I am writing the second equation. This is the equation 1. So in equation 1 solving, and this is the equation 2. So wherever minus V1 terms are there, so 1 by j, minus 1 by j is plus j, and minus 1 by 5, 0.2. So I am writing first V1 terms. So minus 0.2 j V1, and here V2 minus V1 by J10 is there. So anyway minus 1 by j plus j. So plus 0.1 j V1. So V1 terms are over. Come to the V2 terms. So V2 terms are this is having only real value. There are no other real value. So V2 by 10, that is nothing but 0.1 V2. And V2 by J5, So minus 0.2j. So 1 by 5 is 0.2. So minus 0.2j V2. And here minus 1 by j V2 by minus j5. So anyway these get cancelled, right? So 0.2j V2. Anyway this get cancelled. Any other? Okay. And V2 term is here minus 0.1 j V2. So minus 0.1 j V2. So so 0.5 at an angle of minus 90 is nothing but sorry, 0.5 at an angle of minus 90 is nothing but it consisting of only imaginary, not real. So that is nothing but minus 0.5 j only. So if you write in the right side, it becomes plus, so 0.5 j. So if you have doubt, so 0.5 into cos of minus 90 plus j sin of minus 90, you would do it. 0.5 at an angle of minus 90 is nothing but 0.5 into cos of minus 90. Cos of minus theta is cos theta only. Cos of cos 90 how much? 0.
0, sir.
Yeah, plus sin of minus 90. Sin of minus theta is minus sin theta. So minus sin 90 is 1, minus 1. So minus 0.5 j. So that if you write that in the right hand side, 0.5 j. So result equation you write it. So 0.1 j V1 and minus 0.2 j V1. So it will come minus 0.1 j V1. And what are the V2 terms? Here V1 term only over, V1 term is over. So V1 0.1 V2. So this is imaginary is there. Sorry, real is there. And what are the imaginary terms of V2? Only minus 0.1 j V2. So minus 0.1 j V2. I am common the V2 is equals to 0.5 j. So now you can apply Cramer's rule for solving these equations 3 and 4, or any other method also you can solve that. So I'll solve the equations 3 and 4. So this is how much? So equation 3 is modified, right? 0.2 here minus j 0.1. So solve the equations 3 and 4. You will get V1 as, hope you know how to solve the equations. 1 minus
Sir,
and V2 is equals to the unit is volts. Since in equation 3 and 4 only there are two unknowns, so two equations. So V2 is equals to minus 2 plus J4.
sir, hello.
Yeah, any doubt?
Hello.
Yeah, any doubt?
Like for alternating current, always imaginary comes, sir.
Come again?
Does imaginary values come always in alternating current from now on?
Imaginary terms are?
Sir, does imaginary terms come in alternating current always?
No, not like that. So those are all imaginary value. 0.5 j is nothing, 0.5 at an angle of minus 90. So just write it is 0.5 j. The value is 0.5 j.
Okay.
So think that only values, those are all values.
Okay.
The current is also a complex quantity. Here in this AC circuit,
Okay.
the current and voltages also they may give in complex quantity. Complex means A plus JB. Like A plus JB is a complex quantity. A complex number is nothing but which consisting of real and imaginary. You try how to you try to do the solving the equations 3 and 4. If you get doubt, I will explain. So now how to convert rectangular to polar and polar to rectangular? Mathematically I will explain. So suppose A plus JB is there, which is given in rectangular coordinates. A plus JB is nothing but rectangular coordinates. So how to convert it into polar? So polar means which have a magnitude that is A square plus B square at an angle of tan inverse B by A. Okay. Hello.
Yes, sir.
Okay, this is A plus JB is given root of A square plus B square at an angle of tan inverse B by A. I have doubt whether it is minus tan inverse B by A or plus tan inverse B by A.
So tan inverse B by A, sir.
Okay.
But then, like, according to quadrant, we have to change, no, sir. Like, you have to add pi and all that. It depends on which quadrant.
For example, in this case 1 minus 2j, the V1 is 1 minus 2j and V2 is minus 2 plus j4. So convert this one to the polar coordinates. So V1 is equals to root of real square and imaginary square. So 1 plus the imaginary square. The imaginary is minus 2. So minus 2 whole square is nothing but 4. So and tan inverse B by A. B is minus 2 and A is 1. So tan inverse of minus 2. So if you have calci, you can check it. Root 5, I think 2.2 something comes. Root 5 tan inverse. So this is in polar form. How much? What is the tan inverse of minus 2?
So, tan inverse, 1 second. Yes, sir.
How much?
Tan inverse minus 2. Sir, negative 63.43.
Yeah, correct. So 2.24 at an angle of minus 63.4. So you can write this polar form by using so one more way we can write. So V1 is equals to 2.24 cos of
Cos theta I minus.
Cos of omega t minus 63.4 degrees. So this is nothing but 63.4 degrees is nothing but phase shift. We can write in this way also. V1 is equals to 2.24 into cos of omega t minus 63.4. So similarly convert the V2 into polar form also. So V2 into polar form. So V2 is equals to root of, so 2 square is 4 plus minus 2 whole square is 4 and 4 square is 16. Tan inverse of 4 by minus 2. See, this is not same as like previous one. Previous one is 1 minus j2. So 1 minus j2 means which quadrant will come? So real is positive and minus 2j. That means it is comes in the fourth quadrant. So that's why minus 63.4 came. See, minus 63.4 means so this is the fourth quadrant. So this is 0 degrees. Clockwise is negative and anti-clockwise is positive. So minus 63.4 somewhere here. And here in this case V2 is equals to minus 2 plus J4. So that means tan inverse of 4 by minus 2. Tan inverse of 4 by minus 2. This is in which quadrant? Tan inverse of minus 2 plus J4 means which is in the second
second quadrant.
Second quadrant.
So it's going to be tan inverse.
And 90. So root 20 how much? 4.47. So tan inverse of 4 by minus 2, that means pi minus tan inverse 2. So pi is 180 degrees minus tan inverse 2. So 180 degrees minus 63.4. Correct?
Sir, it is 116.6.
Yeah, correct. So this is V2 in polar form. So you can use your scientific calculator also how to converting the polar to rectangular and rectangular to polar. Suppose if the given is rectangular, so you need to convert it into polar, then pole in your scientific calculator, pole option is there, pole bracket, POL, that you press it and give the real and imaginary value, so you will get the in polar form. I hope you know this.
Sir, I know how to convert by hand, sir. Actually, for us, we are not allowed that level of calculator here.
Oh, in exams, they are not allowing?
No, sir. Like that level, they don't allow. They are allowing some basics. In this one, they don't have all that, sir.
Okay. So, any doubt in this problem?
No, sir.